Today is May 14th, and we're going to be proving trig identities again today. So this is day 2 of this, okay? Today what we're going to be doing is we're going to look at problems where it's good to work on both sides, okay? Now that doesn't mean you move stuff from the left side to the right side or right side to the left side, because you can't do that because you're assuming it's equal, right? We're trying to show that these two are the same thing, okay? And the only way to do that is to show that they perfectly match, okay? And so we're just going to work on one side and rewrite it one way, and then we're going to jump over to the other side and work it and just show that they are going to be the same thing at some point. Okay, all right. So right here we see on the left hand side the cotangent squared u, right? So we should be thinking a Pythagorean identity. Okay, so anytime we see a squared trig function, we should be thinking some type of Pythagorean identity. Okay, so we know that cosine squared theta plus sine squared theta is always equal to 1, okay? So we can get a cotangent squared theta out of this by dividing both sides of this by sine squared theta, okay? So if we take this cosine squared theta and divide by sine squared theta, we would get cotangent squared theta. And if we took sine squared theta and divided by sine squared theta, we'd get plus 1. And then if we took the 1 and divided by sine squared theta, we'd get cosecant squared theta, okay? Now we can move stuff around, and we could write this as cotangent squared theta is equal to cosecant squared theta minus 1, okay? Now, so that means up here, now instead of thetas, it's u's, okay? All right, but we can replace this cotangent squared u with cosecant squared u minus 1, and that's what we're going to do. Okay, so I'm going to come over here to the left. So cosecant squared u minus 1 over 1 plus cosecant u. And we just, all we did, and we need the equals too, okay? All we did was we switched this cotangent squared u with something that it's equivalent to, okay? Now, here's the next thing on this side, okay? You notice, okay, this is a difference of squares, right? Because cosecant squared u is a perfect square, minus, that's a difference, right? And then 1's also a perfect square, okay? So we can factor this. This is a difference of squares. So this factors into cosecant u minus 1 times cosecant u plus 1 all over, okay? Now, if you look at this, both of these start with cosecant, right? So it would be nice if we wrote this with starting with cosecant, right? And we can because it's addition, and the order doesn't matter when you're adding, right? So this could be written as cosecant u plus 1, okay? And then we need the equals, okay? And then this cosecant u plus 1 and this cosecant u plus 1, this came from multiplying two fractions. One of them was this over this, which means it's a 1, and these cancel, remember, okay? And then you're left with cosecant u minus 1. Okay, so that's pretty simple, right? We've simplified that left-hand side as much as we could. So now we want to jump over to the right-hand side and simplify that one, okay? All right, so back over here, we have cotangent u, right? And so we could change these to sines and cosines, okay? So this cotangent u could be rewritten as cosine u over sine u, okay? And then secant u could be written as 1 over cosine u. And then minus, and then tan u could be written as sine u over cosine u. Okay, well, where could you go? Because that looks more complicated, right? Yeah, but what you could do now is you could multiply this out, right? And you could have multiplied it out earlier too and wrote cotangent u secant u minus cotangent u tan u. You could have done that too, okay? So there's not just one way to do these either. The bottom line is you just got to get them to match up, right? And you show it through a series of steps, okay, that the left side and the right side are the same thing, okay? So now what I'm going to do is I'm going to multiply these two together. So that would give you cosecant, or not cosecant, cosine u over sine u cosine u. And then minus, and then we got to multiply this with this fraction, right? So this would be cosine u sine u over sine u cosine u. Okay. Now, if you look, these cosine u's right here, we can cancel, right? Because this is a product, and this is a product because it's a product of 1 times cosine u, right? So we can cancel, right? Then over here, sine u times cosine u, and the top is cosine u times sine u. So we could cancel those too. So sine u over sine u makes 1, and times cosine u over cosine u, that makes a 1, right? Now, it doesn't mean everything's canceled out and there's a 0 here, right? What's cosine u over cosine u? It's 1. What's sine u over sine u? That's 1. 1 times 1 is 1. So it's 1, right? Okay, so this side becomes 1 over sine u minus 1. Okay, they don't match, right? Well, what can you do? Well, 1 over sine u is really cosecant u, right? So that means cosecant u minus 1 is equivalent to cosecant u minus 1. So they are the same, right? Okay, now I want to go over some, I forgot, and we got to go over, I want to write over here to the side some of the identities we used, right? So to go from here to here, we had cotangent theta is equal to cosine theta over sine theta, right? We use that identity to go from cotangent u to writing it this way. We also use secant u is the same as 1 over cosine u, so we use that one. Or theta. Okay. You could have used u, writing u here too. Okay. So that's what allowed us to go from here to here. And we also use tan theta is equal to sine theta over cosine theta. And that allowed me to go from here to here. Okay. And then I used just algebra, right? And multiplied it out. Okay. And then we could do some canceling because this was a product and this was a product, right? And we got this. And then we use the fact that cosecant u is the same as 1 over sine u, right? So cosecant theta is the same as 1 over sine theta. See, there's a lot of identities we used in this problem, right? We used 1, 2, 3, 4, 5, 6 different identities to get down to show that these are the same thing. Okay. All right. Let's go to the next problem, okay? Or the next page. We're going to talk a little bit first, okay? And then we'll do the next problem. There's only 2 examples today, so this is kind of a short lesson. Kind of nice, right? Okay. We have like 1 week left, guys. 1 week. All right. Okay. Hang in there. Stay tough. Stay tough. Be a bear. Okay. So in calculus, okay, a lot of times, okay, we want to take something that's complex and then use identities to make it simpler. And I've talked about that, right? But occasionally, okay, we need to take something that's simple and make it more complex in order to do calculus on it, okay? So these are just a few of them, okay? Some of these I've given you in homework, okay? And we want to prove that these identities work, okay? So we're going to look at this next one that's a useful one that's used in calculus, okay? All right, and that's the sine squared x cosine to the 5th x is equal to this, okay? To this expression, okay? So definitely the more complicated side, I would say, is this side right here, okay? And so we're gonna work on this side a little bit, okay? All right. So let's jump in and do that one. Okay. So what I want to do is work on this right hand side, okay? So I want to show that sine squared x cosine to the 5th x is equal to this, okay? So we're going to write, let's just start, write sine squared x cosine to the 5th x is equal to, okay. So right off the get-go, okay, so I have a cosine x here, right? That's going to, that right here, this cosine x right here is one of these, right? So I'm going to need 4 more of them. I'm going to be needing to multiply this one by 4 more cosine x's, right? So somehow I'm going to have to get cosine to the 4th x out of this, okay? So one thing you can look at is, okay, so we have a sine squared x minus 2 sine to the 4th x, okay? And that means sine x 4 times, right? And this one means sine x twice, right? Sine x times sine x. And then plus, and then this one is 6 of them in a row, right? So if I have 2 of them here, and I have 4 of them here, and I have 6 of them here, each one of these has at least 2 of them, right? Which means there's a GCF here of sine squared x. So I can factor a sine squared x out of these 3 terms, okay? So that's what I'm going to do. And then parentheses, okay? So I factored the sine squared x out of this one, right? So it's going to be left with 1 minus, okay, 2 of them have gotten pulled out of this one, right? So minus 2 sine squared x. And 2 of them have been pulled out of this one, right? So plus sine to the 4th x, close the parenthesis, and then parenthesis cosine of x. Okay, now I'm going to tell you something. I know I'm on the right track. What? How do you know that? Okay, the reason I know that is because look over here. I have a sine squared x. Look what I just pulled out, sine squared x. I've got that part taken care of, right? This part right here, the sine squared x, has already been done for me, right? It's done, right? So that means this is going to have to become the cosine. This is going to have to be, this is going to somehow become the 4 cosine x's that I need to multiply together to get this one, or to get cosine to the 5th x, okay? All right, so how is that going to work, right? Well, here's the highest power for sine x, right? So I'm going to rewrite this, okay? So I'm going to write the left-hand side. Okay, so sine squared x cosine to the 5th x is equal to sine squared x. Okay, and then what I'm going to do is I'm going to write the 4th power of sine x first. So sine to the 4th x minus 2 sine squared x. And then that's just a positive 1, so plus 1. And then times cosine of x. Okay, now this is like quadratic form. Okay, in fact, it is quadratic form, right? Okay, so we want to find 2 numbers, okay, that are going to multiply to give you 1 and add to give you negative 2. Okay, multiply to give you 1 and add to give you negative 2, right? And it would be negative 1 and negative 1. Okay, so that means this factors, okay? But instead of sine x minus 1 and sine x minus 1, it's going to be sine squared x minus 1 and sine squared x minus 1. Okay, so this is equal to sine squared x, and this factors into sine squared x minus 1, and then times sine squared x minus 1, right? Times cosine of x, right? Okay. Sine squared x minus 1, right? Sine, that's a Pythagorean identity, right? Yeah, because cosine squared theta plus sine squared theta equals 1, right? So if I move the 1 over here, right, and I move the cosine over to the other side, I'd have sine squared theta minus 1 is equal to negative cosine squared theta, right? And I'm going to write this, okay? So sine squared theta minus 1, so sine squared theta minus 1 is equal to negative cosine squared theta, right? I'm just manipulating, I'm moving stuff back and forth, right? Because this one we've already established is true, okay? So we can move, we can treat it like an equation, we can move stuff to left side and right side. We can't on this until we establish that it is in fact equal, okay? All right, so how does that help me? Well, that helps me because this becomes a negative cosine squared x, okay? So equals, and you know what? I'm gonna stop writing on this side, okay? And maybe I'll come back at the end and fill it in. Okay, so sine squared x, and this becomes, so I'm gonna put a parenthesis here, negative cosine squared x times a negative cosine squared x times cosine of x. All right, so this is sine squared x. What's a negative times a negative, right? Well, that'd be a positive, right? And we would add these two exponents because we're multiplying. So this would be cosine to the 4th x, right? So times cosine to the 4th x times cosine x. Now, I could also use parentheses instead of the dots, okay? or even if you put them next to each other, right? But now here I have 4 of them, and here, remember I said we need 4 of them, right? Here I have 4 of them, here I have 1 of them. I've done it, right? So I've established that this is equal to sine squared x cosine to the 4th of x, right? All right. And then that's what we have over on this side, or not. Oh my goodness gracious, guys. I say it and then I didn't write it, huh? Or maybe I didn't even say it. I don't. Okay. What's 4 and 1? That's 5, right? So this should be a 5. Okay. You can catch mistakes like that, right? Like, wait, they're supposed to match. They didn't match, right? Silly, silly, silly. All right. So we've established that this left side and the right side are indeed equal, which means everything came from logical steps from manipulating this right-hand side, right? And getting it down. And so we've just proven that this side and this side are in fact the same thing. These are equal, okay? And that's really proving identities. Now, I'm not going to say this is the most important thing. Like some of the work we're doing is harder than what you'll actually see in calculus, okay? But you do need to know, like right off the get-go, like tan x is the same as sine x over cosine x, okay? You're going to have to make switches like that a lot, okay? But simple ones, like 1, not quite this complex usually, okay? All right, you guys, that's it. Let me get the assignment sheet. And you guys, I sent out a survey that I'd like you to complete. For some reason, when you guys signed up for classes, Aries did not quite take in the information correctly. So we don't have an accurate count of how many people are going to take calculus next year. So I'd like you guys to fill out that survey so we can get an accurate number. Now, please, 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 like you're one of the people that I don't want to take calculus. Okay, that's fine. I am happy if you're taking a math class. I'm a happy teacher. Okay, I just want you to take a math class, and I want you to be happy with the math class that you take and you have fun with it. So if you think AP Stats is that, you take AP Stats. If you think Trig Pre-Calc is that class, you take Trig Pre-Calc. Okay, I am a happy teacher. Okay, I just want you to take math. That's all. Okay, all right. You guys, that's it for, that's not it for today, right? I got to get the assignment. Let me get that. Okay, guys, what I would like you to do is today we did proving identities day 2, okay? And so I want you to do worksheet TEI 5, okay? So that's May 14th, okay? So we've got, this is Fridays, okay? And then Monday, Tuesday, Wednesday, Thursday, and Friday, and we are done, guys. We're done. We're going to be done. Closing in, okay? I get a little sad, okay? Even though this is really weird teaching this way, okay? All right, you guys, you have a wonderful, blessed, absolutely best day ever today, okay? You guys take care. Bye.